This week we're going to talk about conda environment files. What are they? How can you make them? And how can they make your life easier? Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to talk about conda environment files, something that we've touched on in the past, but I want to go a little bit deeper because these are so incredibly useful, not only for your research, but when publishing or even creating an operational product. So an environment file is a file that describes a Python environment completely. What Python is installed, what packages are installed, how they're installed. It can even contain version restrictions, such as the package must be before a certain version, or after a certain version, or it must be exactly a certain version. Even better yet, those files are operating system independent. So they'll work if you're sharing your work with somebody on a Windows system and you're on a Mac or on a Unix system. And this is because they're just a simple text file. They're a YAML file, which YAML stands for YAML 8 Markup Language. And these are really easy to commit to a repository. In fact, it's best practice, in my opinion, to version control this file, so you know how your environment has changed over the years on your project. But this is also just a simple text file, so it makes it very easy and lightweight to share with others, and they can recreate your identical environment or an environment similar to yours. So why might you want to use one? Well, we've already talked about sharing with others, so that enhances the reproducibility of your work. It also makes it really easy to switch laptops or switch desktops or run on a cluster, because you have a file that describes the environment that your code needs to work. I always used to think about the test of what would happen if I dropped my laptop and it got run over in front of me. How sad would I be? And I always tried to keep that to not very sad, because I've got everything backed up and all I have to do is either restore that backup or more than likely just recreate it again, because I'm mostly cloning Git repos and creating environments, and I don't really need a backup for that. Also, it helps you set your environment back. You can just blow away an environment and recreate the environment if somehow something happens to your old one. Something gets damaged, corrupted, your script accidentally starts recursively deleting something in the environment. That's okay. All you've got to do is blow it away and start a new one with the environment file. So what does an environment file look like? Let's create one. So open your favorite editor. I'm using Atom here. And we're going to first give our environment a name. You can call this anything. Unidata is often the one that I use for my daily computations. I'm going to call it myenv for our demo. And then we need to specify what we want in that, and those are called dependencies. A couple spaces, a hyphen, and your dependencies. So I want Python, I want pandas, and I want xarray. Looks like we're well on our way to making a pretty nice environment for data analysis here. So I'm going to save this file. Generally, we just call it environment.yml. That's what conda is going to look for by default. You can call it anything you want and just tell conda what the file name is with the -f option. But I generally just stick with the default, so I don't have to type as much, because remember, programmers are lazy and we don't like typing. Okay, so let's save this file and see what happens. All right, so I saved this as environment.yml on my desktop. I opened an Anaconda prompt to my desktop here, and I'm going to run the command conda-env create. So what this is going to do is create an environment, and since I didn't specify anything, it's going to look for environment.yml, and once it finds that, it's going to then see what it needs to do to create an environment called myenv with the dependencies Python, pandas, and xarray, and it's going to go ahead and do that. Now it'll take just a second here, and then we'll have our environment. All right, so now we've got our environment created, and it tells us that we can activate and deactivate it as we normally would. So that's pretty simple. I also mentioned that we can pin packages, so let's take a look at how to do that. Let's say I wanted to restrict to Python greater than or equal to 3.6. Now normally we're going to try to install the most up-to-date Python, just with no specification, but as the solver goes through and looks at all of your dependencies, maybe you have a dependency that requires something earlier than you want. You want to be alerted of that. We can specify that we want Python greater than or equal to 3.6, for example. Or I could specify a specific version. For example, maybe I want pandas 1.5 only. Nothing more recent, nothing older. Now that one's a little risky. That really reduces the solver space of what packages can work. I generally stick to greater than or equal to, less than or equal to, or not equal to. Not equal to is especially useful if there's, say, a bad version of a package that gets out and that breaks your code because of the way something worked. You can say, I don't want that to be installed ever. Or maybe, as when NumPy updated some things a few years ago, a lot of people had to specify a less than or equal to until they could get their code up to date. So pinning packages can be a useful thing. But more often than not, in science, we need to install packages from different channels. The default channel that has all the Anaconda defaults is great, but oftentimes we might want something through conda-forge. Maybe it's a more up-to-date version because it's not waiting on the verification with the whole Anaconda suite, or it's just not available there. Maybe it's a very domain-specific package that's only in conda-forge. So we can specify channels in a channel list, and we can use these in order. So I want to use the conda-forge channel first, and then if that doesn't have it, I want to use the default channel. We could also add some more dependencies. For example, MetPy, siphon. We could add matplotlib, though it would get brought in as a dependency with others. And you could keep going until you build out your entire environment. But even then, sometimes things aren't available from conda-forge or the defaults channel, and you might have to install with pip. All right, so to do that, we list pip as a dependency, and then a colon, and then we list the packages that we want to install. So for example, cfgrib is one that's commonly installed with pip. And we've talked about cfgrib very recently in MetPy Mondays. So we can save that, and now we have our environment file that has fully defined, let's say, our grib experimentation environment that we're just calling myenv. Now maybe your environment has a lot of things in it you've kept adding while you're working on your project, and you're not really even sure what all you installed. Sure, you could create an environment file from scratch and then try to run all your scripts. That's probably not a bad idea. But we can do this another way. We can automatically generate the file and then go back in and clean it up some. So let's do that for my Unidata environment. I'm going to activate the environment, conda activate Unidata. Then I'm going to use the command conda env export, and I want to export to a file, unidata.yml. What this is going to do is look at everything that's in there and put it in an environment file. But this installs everything, not just the stuff that I've installed, it's everything that's in that environment, which can cause some problems across operating systems because some of these are pretty low-level packages. In fact, let's open up that file and take a look. Yeah, so in this file, there are many, many, many packages listed. In fact, if we scroll down to the bottom, we're looking at 300 plus lines. And as I said, a lot of these are very low level. There are fonts, there's all kinds of stuff in here. So what about if we do a different option? We can run the same command, but we're going to use the option from history. What this is going to do is just include the packages that you have specifically installed. And in fact, this is generally the better bet when you're trying to share an environment. So let's take a look at that file. Okay, so this file is now only 35 files, or 35 lines long. And these are indeed just things that I've installed. So very useful. At this point, we could almost just share this as is. And this prefix line, you don't have to worry about. It's not going to try to install it in JLeman on somebody else's system. Conda doesn't really use that. It just tells us where this came from. So that's really handy. And in fact, that's the way that I would normally make an environment file, is I've done my research. I created my an empty environment. I install things as I need them, and then I'll go back. It also reminds me sometimes like, oh, maybe I don't need Python barcode, so I can delete that. Now the last thing is, what about if we go back to myenv? So we changed this pretty significantly from when we made that environment. So I'm going to do a conda deactivate. Okay, can we update? I generally just clean the environment off the system, I remove it, and rebuild it from scratch. That often works fine for me. I've got enough other things to do, an email to answer, something that I can do while that's working. But you can update. You can run the command conda env update. So I'm going to activate myenv conda env update. It gives me a warning that says you should actually really put pip as one of your dependencies. Okay, so we should do that while it's running. Specify that pip is a dependency, and then we use pip. All right, so it's good to always read those warnings. And now it's going to go ahead and run, do our solve, and install again. But it's only going to add things or remove things that have changed in the dependency list, which in this case is quite a bit. Now, lastly, what are you going to do when you're done with an environment? Or if you're like me, you want to wipe it away and just create it again. Maybe you want to test an environment file or see if you've got all of your dependencies properly listed. You can conda env remove -- name the name of your environment, so myenv. And that's going to remove the environment. In this case, it says, hey, you can't do that because that's what you're currently in. So we deactivate, do it again, and it's going to go ahead and remove that environment from our system. So I hope that you found this useful and that it's going to make it easier for you to share your environments that you're doing for your research with advisors, colleagues, or even to have them included in the material that's published with your papers. I'll see you on next week's MetPy Monday.